Materialism holds the high ground these days in debates over what in debates over that most ultimate of scientific questions, the nature of consciousness. When tackling the problem of mind and brain, many prominent researchers advocate for a universe fully reducible to matter. Of course, you are nothing but the activity of your neurons, they proclaim. That position seems reasonable and sober in light of neuroscience advances, with brilliant images of brains lighting up like Christmas tree, while test subjects eat apples, watch movies, or dream. And all the underlying physical laws already known. From this seemingly hard-nosed vantage, the problem of consciousness seemed to be just one of wiring. As the American physicist Michio Kaku argued in The Future of Mind. In the very public version of the debate over consciousness, those who advocate that understanding the mind might require something other than nothing but matter position are often painted as victims of wishful thinking, imprecise reasoning, or worst of all, an adherence to mystical woo. It's hard not to feel the intuitional weight of today's metaphysical sobriety. Like pickets charge up the hill at Gettysburg, who want to argue with a superior position of those armed with even more precise fMRIs, EEGs, and other material artifacts of the materialist position. There is, however, a significant weakness hiding in the imposing-looking materialist redoubt. It is as simple as it is undeniable. After more than a century of profound exploration into the subatomic world, our best theory for how matter behaves still tell us very little about what matter is. Materialists appeal to physics to explain the mind, but in modern physics, the particles that make up the brain remain, in many ways, as mysterious as consciousness itself. When I was a young physics student, I once asked a professor, "What's an electron?" His answer stunned me. "An electron," he said, "is that to which we have attributed the properties of the electron." The vague circular response was a long way from the dream that drove me into physics, a dream of theories that perfectly describe reality. Like almost every student over the past 100 years, I was shocked by the quantum mechanics, the physics of the microworld. In place of a clear vision of little bits of matter that explain all the big things around us, quantum physics gives us a powerful yet seemingly paradoxical calculus. With its emphasis on probability waves, essential uncertainties, and experimenters disturbing the reality they seek to measure, quantum mechanics make imagining the stuff of the world as classical bits of matter all but impossible. Like most physicists, I learned how to ignore the weirdness of quantum physics. Shut up and calculate, the dictum of American physicist David Mermin. Works fine if you are trying to get 100% on your advanced quantum theory homework or building a laser. But behind quantum mechanics, unequaled calculational precision lie profound, stubbornly persistent questions about what those quantum rules imply about the nature of reality, including our place in it. Those questions are well known in the physics community, but perhaps our habit of shutting up has been a little too successful. A century of agnosticism about the true nature of matter hasn't found its way deeply enough into other fields, where materialism still appear to be the most sensible way of dealing with the world, and also all with the mind. Some neuroscientists think that they are being precise and grounded by holding tightly to materialist credentials. Molecular biologists, geneticists, and many other types of researchers, as well as non-scientist public, have been similarly drawn into the materialism seeming finality. But this conviction is out of step with what we physicists know about the material world, or rather what we don't know. Albert Einstein and Max Planck introduced the idea of quantum at the beginning of the 20th century, sweeping away the old classical view of reality. We have never managed to come up with a definitive new reality to take its place. The interpretation of quantum physics remains as up for grabs as ever, as a mathematical description of solar cells and digital circuits. Quantum mechanics works just fine, but if one wants to apply the materialist position to a concept such as subtle and profound as consciousness, something more must be clearly be asked for. The closer you look, the more it appears that the materialist position is not the safe harbor of metaphysical sobriety that many desire. For physicists, the ambiguity over matter boils down to what we call the measurement problem and its relationship to an entity known as the wave function. Back in the good old days of Newtonian physics, the behavior of particles were determined by a straightforward mathematical law that read F equals to ma. You apply a force to a particle of mass n and the particle moves with an acceleration a. It was easy to picture that in your head. Particle, check. Force, check. Acceleration, yep, off you go. The equation F equals to ma gave you two things that mattered most to a Newtonian picture of the world: a particle position and its velocity. This is what physicists call a particle state. Newton's laws gave you the particle state for any time and to any precision that you need. If the state of every particle is described by a simple equation, and if large systems are just big combination of particles, then the whole world should have behaved in a fully predictable way. Many materialists still carry the baggage of that old classical picture. It's why physics is still widely regarded as the ultimate source of answer to questions about the world, both outside and inside our head. In Isaac Newton's physics, position and velocity were indeed clearly defined and clearly imagined properties of a particle. Measurement of the particle state changed nothing in principle. The equation F equals to ma was true whether you are looking at the particle or not. All of that fell apart as scientists began probing at the scale of atoms last century early on. In a burst of creativity, physicists devised a new set of rules known as quantum mechanics. A critical piece of new physics was embodied in the Schrödinger equation. Like Newton's F equals to ma, the Schrödinger equation represents mathematical machinery for doing physics. It describes how the state of a particle is changing, but to account for all the new phenomena, physicists were finding ones Newton knew nothing about. The Australian physicist Erwin Schrödinger had to formulate a very different kind of equation. When calculations are done with the Schrödinger equation, what's left is not the Newtonian state of exact position and velocity. Instead, what you get is called a wave function. Physicists refer it to as psi after the Greek symbol used to denote it. Unlike the Newtonian state, which can be clearly imagined as a common sense wave, the wave function is an epistemological and ontological mess. The wave function does not give you specific measurement of location and velocity for a particle. It gives you only a probability at the root level of reality. PSI appears to tell you that at any moment, the particle has many positions and many velocity. In effect, the bits of matter from Newtonian physics are smeared out into a set of potentials or possibility. How can there be one rule for the objective world before a measurement is made, and another that jumps in after measurement? It's not just the position and velocity that gets smeared out. The wave function treats all properties of the particles the same way. They all become probabilities holding many possible values at the same time. Taken at face value, it is as if the particle doesn't have definite properties at all. This is what the German physicist Werner Heisenberg, one of the founders of quantum mechanics, meant when he advised people not to think of atoms as things. Even at this basic level, the quantum perspective adds a lot of blur to any materialist conviction of what the world is built from. Then things get weirder still. According to the standard way of treating quantum calculus, the act of making a measurement of the particle kills off all pieces of the wave function, except the one your instrument registered. The wave function is said to have collapsed as All the smear out potential, position and velocity vanish in the act of the measurement. It's like the Schrodinger equation. Which does such a great job of describing the smear out particles before the measurement is made. Suddenly gets a pink slip. You can see how this throws a monkey wrench into a simple physics-based view of an objective materialist world. How can there be one mathematical rule for an external objective world before a measurement is made, and another that jumps in after a measurement occurs? For hundreds of years now, physicists and philosophers have been beating the crap of each other, trying to figure out how to interpret the wave function and its associated measurement problem. What exactly is quantum mechanics telling us about the world? What does the wave function describe? What really happens when a measurement occurs? Above all, what is matter? There are today no definite answers to this question. There is not even a consensus about what the answer should look like. Rather, there are multiple interpretations of quantum theory, each of which correspond to a very different way of regarding matter and everything of it. Which of course means everything. The earliest interpretation to gain force, the Copenhagen interpretation, is associated with Danish physicist Niels Bohr and the other founder of quantum theory. In their view, it is meaningless to speak of the properties of atoms in and of themselves. Quantum mechanics was a theory that spoke only to our knowledge of the world. The measurement problem associated with the Schrodinger equation highlighted this barrier between epistemology and ontology by making explicit the role of the observer in gaining knowledge. Not all researchers were so willing to give up the idea of objective access to a perfectly objective world. However, some pinned their hopes on the discovery of hidden variables, a set of deterministic rules lurking beneath the probabilities of quantum mechanics. Others took a more extreme view. In a many worlds interpretation espoused by American physicist Hugh Everett, the authority of the wave function and its governing Schrodinger equation was taken as absolute. Measurement didn't suspend the equation or collapse the wave function. They merely made the universe split off into many parallel versions of itself. Thus, for every experimentalist who measures an electron over here, a parallel universe is created in which her parallel copies find the electron over there. The many worlds interpretation is one that many materialists favor, but it comes with a steep price. Here's an even more important point. As yet, there is no way to experimentally distinguish between these widely varying interpretations. Which one of you choose is mainly a matter of philosophical temperament. As the American theorist Christopher Fudge puts it, on one side there are PSI ontologists who want the wave function to describe the objective out there. On the other side, there are PSI epistemology who see the wave function as a description of our knowledge and limits. Right now, there's almost no way to settle a dispute scientifically, although a standard form of hidden variable does seem to have ruled out. This arbitrariness of deciding which interpretation to hold completely undermines the strict materialist position. The question here is not if some famous materialist choice of the many worlds interpretation is the correct one, any more than whether the silliness of the Tao of physics and its quantum Buddhism is correct. The real problem is that in each case, proponents are free to single out one interpretation over the others because, well, they like it. Everyone on all sides is in the same boat. There can be no appeal to the authority of what quantum mechanics say, because quantum mechanics doesn't say much of anything with regards to its own interpretation. Putting the perceiving subject back into physics seems to undermine the whole materialist perspective. Each interpretation of quantum mechanics has its own philosophical and scientific advantages, but they all come with their own price. One way to another, they force adherents to take a giant step away from the kind of naive realism, the vision of little bits of deterministic matter that was possible with Newtonian worldview. Switching to a quantum field's views doesn't solve the problem. If it was easy to think that the mathematical objects involved in Newtonian mechanics refer to real things out there in some intuitive way. But those ascribing to PSI ontology, sometimes called the wave function realism, must now navigate a labyrinth of challenges in holding their views. The wave function, edited by the philosopher Elisa Nee and David Z. Albert, describe many of these options, which can be pretty weird. Reading through the dense analysis quickly dispel any hope that materialism offers a simple concrete reference point for the problem of consciousness. The attraction of the many words interpretation, for instance, is the ability to keep the reality in mathematical physics. In this view, yes, the wave function is real, and yes, it describes a world of matter that obeys mathematical rules, whether someone is watching or not. The price you pay for this position is an infinite number of parallel universes that are infinitely splitting off to an infinity of other parallel universes that are then split off. Well, you get a picture. There's a big price to pay for the PSI epistemology positions too. Physics from this perspective is no longer a description of the world in and of itself. Instead, it's a description of the rules of our interaction with the world. As the American theorist Joseph Abele says, it's not the electron wave function, it's your wave function. A particularly cogent new version of PSI epistemology position called the quantum Bayesianism or cubism raises the perspective to a higher level of specificity by taking the probabilities in quantum mechanics at a face value. According to Fudge, the leading proponent of cubism, the irreducible probabilities in quantum mechanics tell us that it's really a theory about making bets on the world behavior through our measurement, and then updating our knowledge after those measurements are done. In this way, cubism points explicitly to our failure to include the observing subject that lies at the root of quantum weirdness. As Mermin wrote in the journal Nature, cubism attributes the mother of the foundation of quantum mechanics to our unknowledge removal of the scientist from the science. Putting the perceiving subject back into the physics will seem to undermine the whole materialist perspective. A theory of the mind that depends on matter, that depends on the mind, could not yield the solid ground so many materialists use for. It's easy to see how we got here. Materialism is an attractive philosophy. At least it was before quantum mechanics altered our thinking about matter. I refute it thus, said 18th century writer Samuel Johnson, kicking a large rock as refutation to argument against materialism he just endured. Johnson's stony drop kick is the essence of hard-headed and broken-footed materialist vision of the world. It provides an account of exactly what the world is made of, bits of stuff called matter. And since matter has properties that are independent and external to anything having to do with us, we can use that stuff to build fully objective account of fully objective world. This ball and stick version of the reality seems to inspire much of materialism public confidence about crackling the mystery of the human mind. Today, though, it is hard to reconcile that confidence with multiple interpretations of the quantum mechanics. Newtonian mechanics might be fine for explaining the activity in the brain. It can handle things such as blood flow through capillaries and chemical diffusion across sinuses. But the ground for materialism becomes far more shaky when we attempt to grapple with the more profound mystery of the mind, meaning of the weirdness of being an experiencing subject. In this domain, there is no avoiding the scientific and philosophical complication that comes with quantum mechanics. First, the difference between PSI ontological and PSI epistemological position are so fundamental that without knowing which one is correct, it is impossible to know what quantum mechanics is intrinsically referring to. Imagine for a moment that something like Cube's interpretation of quantum mechanics were true. If this emphasis on the observing subject were the correct lesson to learn from quantum physics, then the perfect objective access to the world that lies at the heart of materialism would lose a lot of wind. Put another way, if cubism or other Copenhagen-like views are correct, there should be enormous surprises waiting for us in our exploration of subject and object, and this would have to be included in any account of mind. On the other hand, old school materialism, being a particular form of PSI will be necessity by be blind to this kind of additions. A second and related point is that in the absence of experimental evidence, we are left with an irreducible democracy of possibility. At a 2011 quantum theory meeting, three researchers conducted such a poll, asking participants, what is your favorite interpretation of quantum mechanics? 6 different models got votes, along with some preference for other and no preference. As usual, as useful as this exercise might be for gauging researcher inclination, holding a referendum for which interpretation should be official at the next meeting of the American Physical Society or American Philosophical Society won't get us any closer to the answers we seek. Nor will stomping our feet, make loud proclamation or name-dropping our favorite Nobel Prize-winning physicists. Given this difficulty, one must ask why certain weird alternatives suggested by quantum interpretation are widely preferred over others within the research community. Why does the infinity of parallel universe get in the many worlds interpretation get associated with the sober, hard-nosed position, while including the perceiving subjects gets condemned as crossed over to the shores of anti-science at best, or mysticism at worst. It is in this sense that the unfinished business of quantum mechanics level the playing field. The high ground of materialism deflate when followed to its quantum mechanical roots, because it then demands the acceptance of a metaphysical possibility that seem no reasonable than other alternatives. Some consciousness researchers might think that they are being hard-nosed and concrete when they appeal to the authority of physics. When pressed on this issue, though, we physicists often are left looking at our own feet, smiling sheepishly and mumbling something about it's complicated. We know that the matters remain mysterious, just as mind remain mysterious, and we don't know what connections between these mysteries should be. Classifying consciousness as a material position is tantamount to saying that consciousness too remains fundamentally unexplained. Rather than sweeping away the mystery of mind by attributing it to the mechanics of matter, we can begin to move forward by acknowledging where the multiple interpretation of quantum mechanics leave us. It's been more than 20 years since Australian philosopher David Chalmers introduced the idea of hot problem of consciousness. Following work by American philosopher Thomas Nagel, Chalmers pointed to the vividness, the intrinsic presence of the perceiving subject experience as a problem no explanatory account of consciousness seemed capable of embracing. Chalmers' position struck a nerve with many philosophers, articulating the sense that there was fundamentally something more occurring in the consciousness than just computing with me. But what is the more? Some consciousness researchers see the hard problem as real but inherently unsolvable. Others posit a range of options for its account. The solution include possibility that overly project mind into matter. Consciousness might, for example, be an example of the emergence of a new entity in the universe, not contain the laws of particles. There is also the more radical possibility that some rudimentary form of consciousness must be added to the list of things, such as mass or electric charge, that the world is built of. Regardless of the direction more might take, the unresolved democracy of quantum interpretation means that our current understanding of matter alone is unlikely to explain the nature of mind. It seems just as likely that the opposite will be the case. While the materialists might continue to wish for a high ground of sobriety and hard-headedness, they should remember the American poet Richard Wilbur's warning: kick the rocks, Sam Johnson, break the bones, but cloudy, cloudy is the stuff of stone. Whew.